Welcome to this quick example of zoning a paddock in the Northern Mallee and implication for VRT. This forms our MSF-led project, Easy VRT, funded by SA Drought Hub and Future Drought Fund. You're listening to Sean Mason from Agronomy Solutions. I'd like to thank David and Anthony Schmidt, who host the paddock, and for letting me drive around to the zones. So just how we start, this is the paddock, obviously quite a large paddock. Google Earth, you've talked about data layers from me before, so this is the initial phase of starting to zone. Quite quickly from Google Earth, we can pick up a grey zone in the northwest, some darker, nice looking soil through the northeast into the middle there, and various implications of different soil types in other parts. So this is how we actually went about zoning and got some really good soil test information. Next layer we used was an NDVI layer 2023, and quite quickly you can actually see some of these soil types matching with this NDVI layer. So this is taken 30th of July. That's when I like to take an image, usually tillering phase of a cereal. Quite quickly, we've got a poor production area in the southwest. That grey soil in the northwest isn't performing that well, but immediately near that is a really good performing early production zone, which it's important because that sets a benchmark for your soil or soil testing. And there's obviously intermediate zones on that eastern side, which lines up pretty well with soil type. Petrolaw has done a EM30 map on this paddock as well. So the cooler colours here indicate a greater conductivity from EM38, possibly constraint driven, but also importantly soil type and water bucket information. So yeah, a lot of conductivity in EM38 readings in the northern sector, and again that southwest sector pops up. So trying to line that up with Google Earth and NDVI can be important. So rightly or wrongly, this is how I set up my zones for sampling. So 6 zones in total, and what I did was a really quick zone map in Excel. This was, and obviously covered it onto the Google Earth. So just trying to highlight what we're trying to hit here. Rightly or wrongly, you can tell me if I have done this correctly. Sample 1, again, as I mentioned, really good performing part of the paddock. This forms a benchmark of what we're trying to hit. So what are the soil characteristics driving this good production? So that's red soil type, high NDVI on the table on the right. A poor, probably intermediate moderate, I've called it. So not as red as the other zones, but yeah, a poor performing part of the paddock. Location 2 in the middle there. Location 3 is probably the worst part of the paddock in terms of early NDVI signals and matches with that grey soil type. 4 is an intermediate. Again, I was trying to get samples in line for fertiliser strip trials. So yeah, again, trying to get an intermediate zone there with zone 4, so moderately performing. And again, trying to quantify what's actually generating this poor performance in terms of NDVI with location 5 in the southwest there. And yeah, the benchmark of the paddock, that blue area, high yielding, really well performing, dark soil type. So again, what's driving that good production as a representation across the whole paddock. So these are the results. I'll just walk you through it. So again, the 6 zones, I've missed out probably the southeast portion of that paddock, apologies, but just running through these soil tests, pH really doesn't give us much, it's all alkaline. Organic carbon does become important in terms of nitrogen and mineralisation, but I guess the profile end buckets and making nitrogen decisions is really important. Obviously a lot of talk about end banking, but so yeah, zones 1, high NDVI, zone 4, moderate NDVI, and zone 6, high NDVI, so good production. We've actually got low profile N. So that gives me a hint that, yeah, it's really good production. There's obviously nitrogen use efficiency. We've got in a lot of removal. We're not actually banking a lot of N because we've got good production. So these are really good, important zones to actually supplement with your nitrogen requirement. In terms of phosphorus, coal P does jump around a fair bit. PBI I do like. It indicates these poor performing zones. So zone 2, 89 is getting elevated, 111 definitely elevated, and 81. And matching that is what we like on this soil type. DGT performs really well on alkaline soils with carbonate. And these high PBI zones, so 3 of them, zone 2, 3, and 5 have got below par DGT, so we're trying to hit around the 70 mark with the DGT. Importantly, just don't do surface soil. So to get profile N, we went to depth, 50 centimeters in this case. And what we can start doing is getting an outline of why we've got nutrient sort of banking in these soil types. So comparing zone 2s and 3 is really exciting for me. We've got zone 2, no constraints. We've got profile N possibly banking a little bit because of our low P and that P fixation with the PBI. But when we compare with zone 3, which isn't far away, we've got constraints kicking in, sodium and salt below 10 centimeters, boron below 30, and we've got this massive nitrogen bank here. So 5 tonne worth, that's quite significant in terms of savings with VRT. Probably don't need to fertilise as much on this zone. We've got these constraints, but we've got low P, so is it profitable to add P in this zone? Hopefully we can find out with 24 trials. So really important paddock, an excellent example of the spatial variability, but also the importance of getting both nutrients and constraints into your test suites. Sulfur is a really nice indicator as well. So along with nitrogen, if we are getting really high sulfur and nitrogen banks, to me that screams that we've got inefficiencies. We haven't got offtake, and there's obviously constraints. That's an obvious one that's leading to that banking. So just quickly in terms of VRT implications, I've tried to demonstrate that with this table. The urea equivalent across these zones, again, amount of urea, so profile N times by the 46% of nitrogen in urea. Again, we can get huge numbers of N banked in terms of urea, so converting profile into urea. The cost across the paddock, so we've already got a lot of money stored in some of these parts. So the question would be, why are we still throwing expensive fertilizer at these? So that's just another way of looking at the fluctuations of zones between these paddocks. Coal P, PBI, DGT, we can start getting some phosphorus recommendations. Again, zones really high profitable but low PBI. We've got really good P efficiencies. We've got good P banks. We can recommend a P rate and a VRT notion of basically replacement. So averaging 2 tonne, we can apply 6. And these zones in this paddock where we've got elevated PBI, we've got competing soil fixation, maybe we can bump that up to 20 as a whole and just convert that to dollars of MAP, cost tonnes per hectare, dollars per hectare, sorry. So we can actually apply the same rate of P, but designating and knowing our zones, we can actually try and maximise crop performance. So as a summary, low phosphorus areas, and this is quite common right through broadacre regions in South Australia. Low phosphorus areas are highly related to high PBI and the matching low early NDVI signal, so your warmer colours. Question mark here, importantly, where we've got constraints but low P, will that zone 3 respond to the extra P even with constraints present? So hopefully we can nut that one out this year. High profile N values are related to soil constraints, so particularly zone 3, and that's important. And then again, hopefully I've illustrated that there's large opportunities that exist here for increasing parcel gross margins by actually putting where your nutrients where the soil can or the crop can utilise it, but also identifying soil types which may compete with that fertiliser for crop uptake, and particularly phosphorus. So love to see the results from this paddock. We have implemented, this is Pete's VRT map, so we've implemented 2 P-rich strips, so the MAP at 80 kilos, so comparing that across some of these sampling zones, so 2, 4, 3, 6, will be really interesting feedback from 2024. So red indicates low VRT or low MAP rates from Pete, low EM38, high EM38 readings from the north and southwest, increasing to your profitable areas where he's throwing more MAP at it. So this is just an in capture on the right here of an NDVI of the approximate strip locations here. We can start seeing some early indications of that strip working, but again, grain in the bin is going to be really important for this demonstration. So hopefully that is helpful. Any questions, please let me know. Signing off. Thank you.